All right, everyone. How we doing today? Doing good? How's the class going? I heard Dr. Pushkin canceled his. Who canceled theirs today? Or was that tomorrow? Is there anyone here in Pushkin's? No, everyone here is from Dr. Zoo's? Oh, so he gave everyone the day off there. Maybe, I don't know. I heard an announcement that he canceled class because they're having an exam next week. So, when's your guys' next exam? Next Tuesday. What's going to be on the exam? Nodal, mesh, op amps. All right, let's go over op amps because that's what we were doing prior to class. So one thing I was trying to show you, someone asked, is there you go. Come on, camera. There you go. Oh, let's do our signature title. EE 220D. Week 9. Today is October 22nd, 2025, page 1. There you go. So, with your ideal op amps, right, you already know what's going on, right? From your homeworks, well, you don't have like a positive or minus supply. Here's VDD plus, VDD plus, VDD minus, correct? It's because you're assuming these are ideal. But in practice, when you're using the LTSpice model, needs this. It basically, you need to add your power supply. So I'm going to show you something about this output. If this were V out, I'm going to color it something different. Let's do, let's just do this plot. And then just do VDD plus, sorry. Then this is VDD, there you go, minus, correct? So if I were to have this op amp, right, and I wanted to just put this voltage on this graph, correct? If, let's just say, I don't know, we got 1 volt here and 1 volt there, what's the difference? 0, right? So then we're going to be like somewhere over here, right? 0 volts, is that good? But then let's just say I move this 1 volt up, right? It goes to like, I don't know, 2 volts now, right? Let me just use a different color. 2 volts, orange marker, right? What's the difference? 2 volts minus 1 volt is equal to a 1 volt difference, right? Is that good? And then if there's a gain in here, I don't know, let's just say it gains like infinity, correct? Any positive, what do you call it? Positive number with a gain of infinity, right? Is just gonna go straight into infinity, right? But in reality, when you're using the LTSpice model, it's just gonna slam to like your maximum right here. Right? But in an ideal op amp, like the super ideal, it just goes all the way to like infinity. Does that make sense? So, well, technically you can't have like an infinity because infinity is just a concept. It's not a real number. Same thing with zero number. That's philosophy. Anyways. So does that make sense? And then, oh yeah, same thing with if you do the following. If you went, I don't know, let's just do 2 volts over here. And then this is 1 volt over here. And then you got, let's call 1 minus 2 condition, right? Minus 1 volt, the difference. If I put 2 volts at the minus and then 1 volt at the plus, right? We're going to get a negative 1 voltage. Just voltage differences, okay? We're not connecting anything. We're just thinking about it, right? With this gain of infinity, right? And minus 1 times infinity gives you negative infinity, right? So it would go all the way down. But in reality, we're capped at this point right here. There you go, volt. All right? Does that make sense for your LTSpice stuff? So if you wanted to, could say you can use like 100 volts or whatever, but let's just stick with 10, plus 10, minus 10. Funny enough, if you want to check if you're doing something wrong, I think all the numbers should add up to something not greater than a power supply. So like if you're messing with like 1 or 2 volts, then your answer is going to be in that ballpark. So maybe set like 10 volts plus or minus 10. So this would be like plus 10 volts and this would be minus 10 volts, right? Does that help a little bit? So yeah, I think, and then I guess I'll show everyone what they were missing during our little introduction. So what I was trying to do was I was trying to create this like ideal model where I got this right here. This right here is a voltage controlled voltage source. And then let me see, voltage controlled voltage source. Got this. I put a resistor here, but tried it and it didn't work as well as I wanted to. It just acted like a normal voltage divider. Treating this as 0. Not so sure why that's the case unless I because the output voltage, output resistance needs to be infinity, but there's no way. We'll figure something out. But I was trying to create a model for you to see if I can make. I'll see what I can do for tonight. Maybe I'll create a model so that you guys can copy paste, or maybe a little tutorial on how to make your homeworks a lot easier. Something you can just copy paste, get done. So, but are you guys using the actual model I showed you in class? Right? Let me try this. This one right here. If I were to go press P for component, right? Oh, actually, that's my working directory, right? Here's your LTSpice directory right there. Normally what it looks like, correct? And then I was trying to do this. It's called the AD795. That's what I picked up, but let me see if there's another way to pick that. Let's go up here. See this right here? This is ADC, comparators, however you want to call it. There's a lot of other components here. Op amps, right? Is that good? So I'm going to double click on this op amp, right? And let's see, I saw this other thing. I saw universal op amps. Maybe that could work. Let me see, because I wanted to use this one right here. You must .lib opamp.sub. You must give the value a name and include this file. I want one with no power supply. No, it's not giving me one. You must .lib opamp.sub. Wonder what that means. It's okay. But anyways, this is the one I like using. But actually, let's just... Do I want to do it? No, let's just do 795, correct? Then what's the next thing you do? 2 voltage supplies, right? Boom. Boom. Correct? And ground. There's got to be an easier way of doing this. Boom. 10 volts. 10 volts, okay? Is that good? And then VDD minus, right? Then VDD plus, come on. There we go, right? And then if I could do Control C, boom, right? Control C, boom, done, right? Easy stuff. If I stretch this wire, boom. S to stretch. Is that good? Now you can do your homework. All right, did anyone have like a homework problem? Or because do we have any of our Pushkin students in here? No Pushkin? I guess they all took a day off because yeah, I got the announcement that their class just canceled today to study. So you guys actually study when they say no kind of class? I don't know. I can't say anything. But it's okay. You guys are getting your money's worth with whatever I can do, okay? So Dr. Zoo's class here, right? All right. You guys are getting special treatment. Let's try something. Let's see. Aha, is this his homework? Does that look familiar? Yeah, let's go. The output voltage of an op amp is -4 when the non-inverting input is -1. If the open loop gain of the op amp is 2 meg, so 2 million, right? 10 to the 6 is million, correct? 2 million gain, right? What's the inverting input? Anyone know what we're doing? Okay, I'm gonna write this. I'm gonna draw a triangle. And let me just do the following. Boom. Minus, plus. Don't worry, I'll put the camera back on. The output voltage is -4. The gain is 2 million. Right? And then the non-inverting is 1 millivolt. Okay? And then it wants to know what this one is. There you go. Does that look like your homework? Well, this is an easy problem. You guys remember the thing? V out is equal to your gain, or I don't know, gain. That's just another way. Gain. Good. Just another marker. Your gain times your V, I don't know, plus minus V minus. I'm using so many annotations, right? You know this, right? This is -4 volts, right? Good. -4. You got 2 million. 2 times 10 to the 6. Good. And then let's call it. We got 1 millivolt at V plus. Does anyone bother if I do this? Or not E. 10 to the -3. Right? And then minus, what do you call it? V minus. Is that good? One equation, one unknown. Solve. -4. And then put this 2 times 10 to the 6, right? And then that goes over here. And then you can just subtract this. I'm going to skip so many steps here. Minus 1 times 10 to the -3 is equal to minus V. Did everyone like what I just did? Is that good? I think there's a way to cheat this. I want to say it, but I don't want to say it yet. Anyways, 2 divided by 4 gives you that right there, and then you got plus, 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 right? And what are we left over? 2. Then this is 10 to the -6. What do you call it? How do I want to say this? Oh, E. Why am I using E? So the reason why I started using E is sometimes the way LTSpice or a lot of engineering annotation works is there's 10 to the 3rd, right? There's another way to engineeringly write this, or what do you call it? 1 times 10 to the 3rd, right? You can write this as 1E3, like that. Is that good? And then there's 10 to the -3, right? 1E -3. Has anyone seen this annotation? This is engineering. That's why I was writing the E's, if anyone was noticing. 7 years, 8 years of practice, he'll get into your brain. Anyways, let's just do this. 2E -6, correct? Plus 1E -3, right? Is equal to V minus. This right here is just basically, how do I want to say this? Well, wait a second. Did I do this wrong? Hold up. This is -4. I did this. It's a 10 to the 6th. Hold up. I think I did something wrong. Let me show you. What I was trying to do. This is why I don't like doing messy work. No more skipping steps. Another way to write this right here, right? We got 2 divided by 10 to the 6, right? It's like, let's just say that's 2 micro, right? And then I got 1 milli, right? Is equal to this. This sounds weird, but were you guys getting this? Is anyone getting that? No? Guess no, maybe. So let's see, what's another way I can solve this? Because I don't have my calculator on me now, but I want to show you guys what's going on. All right, hear me out. This is a bad way of doing it. Don't do this, but it could help. Because my bells are ringing. I have 2 times 10 to the 6, right? And then I have V plus minus V minus, right? If I have a voltage difference of, let's just say, 1 mil, right? Or 1 millivolt, right? Then what's our output? Two times 10 to the 6 times 10 to the minus 3, right? This gives you, what do you call it? 2,000? Is that actually, is that right? Yeah, 2,000. So that means this difference needs to be pretty small. Very, very small. Yeah, okay, so, okay, that's what I was figuring. That's what I was realizing. I was like, does this need to be in millivolts? No, it's going to be a very small number. All right, let's just redo this again. Okay, I got 2 microvolts, right? I'm just putting a random number right there, right? Plus 1 millivolt, right, is equal to V minus, right? Another way to writing 2 microvolts is 0.002 millivolts, right? Plus 1 millivolt. What's that equal to? 1.002. Is that the gain? Is that you guys got? Anyways, you see that gain just threw me off for a little bit, but not that hard, right? Good. Anyways, what's our next problem? We're just going to go down the homework. Who wants to chug this with me? Not that one. You guys can do this one, all right? Easy. You guys already got the answer? Did you guys already sim this? No one simmed this? Let's see. Find the differential voltage and the output voltage. A is equal to what? I think I need to give you guys a model for this. Let me see. Hold up. I think that's what we might have to do. I think we need to do that. The op amp in the following circuit has this, Wait, Ri is equal to 10K. Wait, what? Hold on, let me see what's going on. Ri, this is Ri. Ro, differential voltage, Vd at the output. What? Am I reading this right, y'all? Is this from the textbook? Did you guys find this problem in the textbook? Yeah.
You have to like use the model of like what an op amp is. Like you know the picture that you pulled up earlier.
Oh, I know what you mean. But no, that's another class. You guys want to do that one? This one right here, right? Okay, I see what you mean. Yeah, no, I need to make sure you guys have this model with you. Because technically you can design this in LTSpice and it will work. Where you get the voltage differences. You got this, you got a current conducting in there. There is a current conducting in there, and then you need to use this difference to just output something. So I want to simulate this, but there's no way to simulate it. But what is the voltage difference? Let's just go over it. Page 4. Okay, so we have plus minus, this one's ground, 100K, okay, plus minus 1 millivolt, ground. And this is V out and ground. There we go. Ground plus minus. Is that good? So it says our actual op amp, Ri is equal to 100K. Ro is equal to 100. A is equal to 10 to the fifth. Now let me just show you. Is that good? So the first things first is we've got to transform this, right? We've got to transform this into the actual model of the op amp, right? So the way you can do that is the following. So here's your ground, right? Oh, why am I drawing it like that, right? And then this is V minus or V plus, correct? Okay. And we have this resistor right there, right? And we got, what do you call it? 100K. And I think I saw my mistake. I think I found it. There you go. And then this right here is V minus, right? Is that good? And then that leads to the following plus minus. And then this is 1 millivolt. Good. What about the output? So this right here is V out, right? Correct? But there's another part we need to model. I'm going to color that. Let's just color that blue. Right? I'm going to color this circuit group blue, where we're going to have plus minus our gain, right? V plus minus V minus, right? Is that good with everybody? The voltage. And then we have 100 ohms. Okay, and then here's our port, V out. Is that good with everybody? So punch this circuit here, right? Into here. Okay, so then it turns into this. 100 ohms, plus minus, A, V plus minus V minus. Boom, there you go. Does that look better? You guys like the circuit? Well, it's painful, right? What's the first thing we can try to do? Well, let's see. We have this given right here, right? That's 0 volts, right? 0 volts. Good. Then we have this V minus right there. That's 1 voltage right there. This isn't this node, V out. And then this right here is, what do you call it? Also another voltage. That's just this voltage right there. Is that good? What's this compute to? If we have A is equal to 10 to the fifth, right? V plus is 0, and then V minus is, well, V minus. It's just going to equal this, minus 10 to the fifth, right? V minus. That's the voltage. Is that good with everybody? So now you have this variable right here, this right there, and V out, solve for V out. Is that good? You know what? I think I'm seeing what's going on, and I want to try and solve this another way. I think I saw my problem. This shouldn't be 1 gig. This should be 1. Let me show you what's going on. That's my ideal op amp. Where's my op amp? Let me see if I can run this again. Come on, baby. Let's go. That's 1 volt. It's a microvolt, which means this has to be, boom, baby. Let's go. Is that it? Whew. Okay, I think I built it. Or we built it, okay. Remember how we were talking about we can build this op amp? Look at that. Okay, just to be safe, 2K. Without doing any homework, or just ignore this part. Let me just move that away. Don't think. Okay. What's the gain of this amplifier? 2? Is it really 2? Negative 2, right? So that means if we put 1 volt right there, right, we should get minus 2 there, right? Let's do it. Is that minus 2? Close enough, right? Actually, let me just do this. Boom. Let me just do this. Top is going to be 1 volt. Bottom is going to be, minus 2 volts with a tick of 0.5 volts. 1, 2. We did it. There we go. Anyways, what I was trying to say is, let's see. We want to model this MOSFET. Let me see. Hold up. Let me build a circuit for y'all. So we need a resistor, right? Correct? 100K? Or 100K? Yeah, 100K. This right here is V minus. Just gonna do VM, right? This right here is V plus, right? And then I need a voltage controlled voltage source. That's gonna be called E for voltage, potential or something like that. Actually, no, that's what I'm calling it. Voltage dependent voltage source, but I'm gonna choose this one because I want it flipped. Minus is on the top. Doesn't matter. Yes, no, it's just a symbol, right? I'm gonna put this right here. Then I'm gonna put this right there. Connect, boom. Then here's my resistor, right? 100, right? Let's call this one R out. Op amp. Does that bother anybody? I'm gonna call this one R in op amp, right? That's the resistors of the op amp, correct? Okay, and it's being controlled by this. So if I were to do the following, boom, plus, boom, minus, right? Is that easy? Cool. And then this right here is called V out op amp. Wait, op amp. Is that good with everybody? So hear me out, y'all. Hear me out. Could I just call this my op amp? Yeah? Let's do it. Let's do something funny. I'm going to create a new port. Input, right? Hear me out. Just hear me out. It's going to work. V minus. Okay. V minus is a input, right? Right? Okay. And then let's see. This right here is an output, right? Because we're outputting a voltage, correct? And then what's our gain? This right here is our gain value. Let's see. 1E. Actually, no. Do I want to do that? 10E. Let me see. 1E5. Let's do that. Is 1E5 10 to the 5th? Right? Is that good with everybody? Can we say that this is our ideal op amp? Or non-ideal? Or we're adding a parasitic? Right? So I'm going to do this. Save as. Wrong class, right class, correct? I've made one model. Op amp model, yeah, right? Cool. I'm gonna create a new symbol. Let me see, new symbol. Let's create a line. Draw. We're gonna draw the worst op amp in the world. Boom. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. 5 from here. 1, 2, 3, 4, 5, right? Straight line. Draw this nice little thing. Right? Is that good? Now I need to add pins. We're gonna do was it VM? Yeah, VM on the left. It's just offset by, I don't know, 20. Yeah, let's go. Is that good? I'm gonna put 20 here. VP. Boom. Hello? Hold up. Add pin. Right. VP 20. Oh. I'm getting too excited, y'all. It's going to be on the left. VP 20. There we go. Does that look good? Guys liking that I'm doing this? There you go. It's free content, man. Hell yeah. Right. Let's do 30. There you go. Is that good with everybody? Let me just add 40. See how I'm changing that? If I put 50 right here, offset, right? You see that? I'm gonna draw a funny thing. I'm gonna draw a line. Draw a line from here to here just for completion, because I may have OCPD, you never know. What? Obsessive personality, or OCPD, obsessive compulsive personality disorder, where you get very picky with the smallest little things. Boom, boom. Is that good? Looking good? Can we agree that I'm creating a symbol, right? And this guy right here is our model op amp, right? I don't want to redo this all the time. I'm too lazy, correct? We're too lazy. We want to just get our homeworks done. Good? So I'm just creating a symbol so we don't have to do this anymore, right? So the way I'm going to do it is I'm going to save as our op amp model, correct? That's our schematic. We're creating a symbol, right? Wait, hold on. Op amp. What did I do? Symbol. Op amp model. Save as. Op amp model. There we go. Is that good? All right. Now let's go back to our thing. Ignore that. Screw you. Boom. Boom. New schematic. Okay. I'm going to instantiate that thing we just created. Here's our model, right? Remember? Boom. Right? I'm going to put a ground right here. Put this right there. Okay. I put the resistor right here, another resistor right here. Here's my voltage, correct? Boom. Boom, boom, boom. This right here. V out. Is that correct? Boom. And V minus is actually connected down here. Is that good with everybody? And then let's call this one V minus, right? This right here is Vn. 1 millivolt. What was our resistances? Let me check. I don't remember. 10K and 100K. Okay. 10K and 100K. Is that our homework? You guys ready to roll? Let's roll. 1 second. Boom. Unused port V out. What did I do? That's our op amp model. Oh, guess what? Because I call it V out op amp, correct? So I have to create that in the actual symbol. Wrong symbol. Get out of here. Boom. Op amp model, right? V out op amp. You see, now they're connected. Is that verifying that everything's making sense? Okay. save button. That's our thing. Now let's run it. Boom. Okay. Let's see what we have here. Get rid of all these other windows. Here's our VN, right? 1 millivolt. Here's our V minus. What's the answer? 100 nanovolts. Is that correct? Is that what you guys were getting? Who solved this problem already? You got 100 nanovolts? What'd you get for? About, yeah, minus, what do you call it? Minus 9.9999 millivolts. So practically minus 10 millivolts. Are you happy? Do you feel great? Now you're like, gosh, like I don't have to use ChatGPT to hopefully find the answer. Now I have an actual calculator that can do it for me. Is that good with everybody? So you guys want me to send you guys this file, and then, or actually better yet, I'm going to send you guys this file, but you guys can also build your own. This is a very quick tutorial on how to make your own op amp. All right, and then forget your name. Dylan. Remember how I was telling you about the voltage rails, like minus and plus? This model doesn't depend on it. All right, so it's just mathematical. So you can use this symbol. Okay, I recommend it. We just built this. Yes, what's up? Okay, so that's the other thing. So that's why I think I need to tell you with precaution is here, we just created this right here, right? This is what you're going to use if the problem says, oh, I have, I don't know, a gain of 20, right? And then you have a crappy, I don't know, resistance of 1K, right? And then this right here is going to be I don't know, you have the worst op amp, screw you, 10K, right? You can play with this, right? Control C, Control Z, Control Z, right? So this right here is our model where you can play. That's why I call it model, right? Okay? Control S. I'm going to go back to our ideal. Does it bother anybody if I do the following? I'm going to save this. Okay? Save. I'm going to save this as, right? Okay? As our ideal op amp, correct? Okay? I'm going to be rewriting it, all right? Boom. So now that's our ideal op amp, correct? Control S. Our ideal op amp, ideal is going to be 0.0, I don't know, let's just do 1E minus 3 or something like that for a 1 milli ohm resistor. Is that good? It has to be, if you put 0 there, it's not going to work, okay? Because LTSpice needs to have some little bit of resistance, all right? Then the resistance here has to be 1 gig, right? Or 1E9, correct? And then our gain here is also going to be I don't know, 1E12, very high gain. That's 1 tera gig, because 9 is giga, and then 12 is tera. And then what's 15? I don't know. But I'm just stopping at 12. Is that good? We're going to call this our ideal op amp, okay? And then, does it bother anybody if I do the following? Where if I do okay, this right here is our model, right? I'm going to add a text and call this one a model or practical model, right? And I'm going to just put this as small font, okay? Right? Is that good? Control S, okay? I'm going to save this, okay? I'm going to save this as our ideal symbol, okay? Yeah, sure. And this is our ideal symbol. I'm just going to delete this. Hello. Delete is backspace. Boom. Okay? And then, actually, no. Control Z. Ideal model. Is that good? Okay? So let's go back to our schematic, right? Our problem, correct? Let's run this again. Are we getting our same numbers? Actually, let me just delete this. Yeah, sure. That's all right. Ideal op amp. Hold up. Ideal op amp. Okay, that's our ideal op amp. Control S. Double click on the symbol. Okay, good. Sweet. Is there anyone following what I'm trying to do? Okay, anyways. This is our ideal op amp schematic, correct? It's ideal, okay? I'm going to add a text. Text. Ideal model. Okay, I'm just going to put this right there, right? Okay? Is that good? And then if I double click on this symbol, it should connect to the actual circuit, okay? I'm going to put this one as practical model, okay? Whoa, there we go. Is that good with everybody? All right, I'm just making sure you guys know that this right here is your practical model. You can do whatever you want with it, okay? Whatever homework you have, input resistance, output resistance, gains, this is your circuit, okay? Is this going to help you? Anyways, exit out of here. Boom. Okay? So let's just use our ideal model, okay? I'm going to delete this. Look at that. Ideal practice, okay? I'm going to use my ideal model, place, boom. Let's see what I get if this was an ideal op amp. What's 12 femtovolts? Very small, right? I just use VN. Yeah, very small, correct? What's V out? If this was an ideal, actually, yeah, look at that. If this was super ideal, yeah, you get the -10. Is that good with you? All right, you feeling it? You feeling good? But the difference right there is like, that's 8. That's tiny, right? That's practically 0. But if I replace this back, Control Z, right? Practical model. Watch our VM, right? 100 nanovolts. We did it, right? You like that? All right. Wait, don't Control S. Oof. Save as, I'm going to call this one, oh, wrong homework. Guys like this, you guys are seeing this when you're taking my lab next semester, okay? EE221, level 2, circuits level 2. Okay. I'm going to call this one EE221, LEC 9, EX, or homework. What chapter are we on? 4. What problem was this? Problem 2? Okay. Prob 2. You like that? I did your homework. Go home. All right, I'm playing. No, don't go home. We still have like 15 minutes left. What's our next problem? You guys want to do this one? No? Which one do you want to do?
Can you use it to model like maybe like that one thing?
Wait, this one?
Yeah.
Sure.
Oh wait, that one has no numbers. Like,
No numbers?
that's just gonna give you an equation. Can you do?
Well, how do you want to do it? Well, I'll show you. Let me show you this. Replace V1 and V2 with 1 volt. Okay? Is that good with you? No, it wants it in terms of this and that. Never mind. You won't get a number. You'll have to actually prove that. So basically this right here is V1. You like this PowerPoint, V2. Then you got this voltage, which is 0, right? Ideally, correct? So basically you have a 1 volt and a 2 volt, and then you have the currents, right? They're meshing in here, right? Let me see. Determine V out and VO. No, this is just a current. This is just a current. This is going to ground. You have current going in here. Boom, boom, boom. What's another problem?
Can you simulate number 6?
Number 6. Ooh, tricky. All right, let's do it, man. You guys like this, huh? Voltage, boom. Resistor, boom. Man, you guys like that I can just magically do this? Oh, he's doing magic. It ain't magic. Friendship is. Anyways, ideal, right? That's what we just invented. We just made this. It feels good, okay? Put this puppy there. Why did I put V minus on the top? Because we got V minus there. It's to match our homeworks. If this bothers you, you can flip this around in the actual symbol, okay? So whatever you want. Anyways, boom. Give it some space. Boom. 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 And then this right here goes down. Boom to ground, correct? This also goes to ground. Boom. You like that? And then this right here is a resistor that goes to ground. Did you guys solve this problem here already? Let's see. 1 volt. Oh, 1 volt. 2K. 4K. Another 4K. 10K. And 5K. And it says you want to know the current. Okay. Guys, remember that? Did I show you guys how to do a dummy voltage supply? You guys remember that one? So I'm going to do the following. Press S to stretch, right? Didn't do it right. All right? Voltage. You know current in a voltage supply goes from plus to minus? Boom. I'm going to put 0 volts, right? It's just a wire, correct? I'm going to call this one current in output. Is that good? Easy? Who's ready to sim this? Yeah, let's sim it. Before that, I got OCPD. Let's make sure everything's good. Boom, VN, V minus, good. V out, boom. Is that good with everybody? 1 second, boom. And let's just get rid of all this stuff. Boom. Yeah, no need. And what is this? No. Run this. Boom. There we go. VN, right? 1 volt. V out. Let's see. Minus 1.25. Is that good? What's the current? Minus 375 microamps or minus 0.375 milliamps. Is that good? Is that what you guys got? No? Well, what happened? Well, you have the current going in here, right? That right there, this right here is about minus 250, correct? Then you have the current going out here, right? Which is minus 125, right? Let me show you. Okay, I don't like when people get lost. Okay, page 5. Now let me just remember that circuit. I'm going to do the following. We're going to try something new. There you go. Boom. Okay, so this is minus, right? This is plus, correct? V out, correct? And then, what was V out? Okay, 5K. Good. Okay, and then there's a 4K. And then yada, yada, yada. And is that good? Correct? Choose your direction, current direction. Want to go up or down? Down? Right? Call this one I1, right? Which way? to the right. I2, correct? And then let's just do I0, right? What are we going to do? KCL, right? So KCL states I in has to equal I out, right? All the sums, correct? So what's going into the node? We got this I0, right? I naught plus I2, right? Is that good? Which is equal to what's coming out, I1, right? So I0 is what we want, right? I1 minus I2. Is that good? Which is equal to what's I1 in terms of V out and 5K? Yeah, there you go. Then minus I2. Actually, this is 0, right? Yeah. What's the voltage over here? 0, right? Because it's grounded, correct? Then what's the voltage over here? V out. So if I were going to plus to minus, right, it's going to be, well, let's just do this for completion. Vm minus V out over 10K. Is that good? Solve for I out or I0. Is that what you're going to do in your homework? Make sense? Now let me just check one thing. 1 volt, 1 volt, 1 volt, because you need this 1 volt to induce current going into here, because you have current going in. Someone's asking, David, like I see 0 over here, and there's a 0 over here. Doesn't that mean that should be 0 too? Well, it's because we got I, big I, coming there. And what's big I going to go? Or actually, better yet, what's I here? I. What's II equal to? We're just calling this II going into the op amp. What's the current? Does that make sense? 0 current goes into the op amp. Is that good? I'm seeing blank faces. Did we forget? The current going into this is 0, right? So that means what is I, this big I equal to, or I2 equal to? That big, whatever I is coming in there, right? So that's why you need this voltage over here. It's going to create a current that's going to roll all the way over here, okay? And it's going to go all the way here, and that's where you get your amplification. That make sense? And then what are we going to call this? Save as, what's our homework problem? $16? Problem 6? Save. We're using our ideal model. Any last homework problems we want to look over? You guys are going to look over KVL, KCL, mesh circuits, nodal analysis. You guys know how to do op amps now? You guys now have that ideal model of an op amp, a practical model of the op amp. You guys know how to find the gain V out over Vs, right? In terms of voltage. If I were to throw 1 volt, what's V out? Just multiply this by the gain. Is everything understood? Actually, let me show you what I mean. Use this problem as an example. 5. This is page 6. Let me use this other marker. Plus minus Vs, and I don't know. Let's see. Plus minus. Wait, hold up. Plus. Yeah, okay. minus V out. Okay, just to quickly wrap this up. Okay, I just drew a random circuit, okay? Oh, well, there's just the problem, right? What's the gain of this circuit? Or, actually, no, we'll make it simpler. To find the gain, right, we're going to wiggle this voltage, right? Let's just say I tickle it a little bit, right? But it's going to amplify whatever, based on whatever the gain is on the circuit, correct? So the gain in circuit is going to equal the output, right, over the input, right? Does that make sense? So I'm going to do something funny. Okay? I'm going to do something very familiar. V, S, and then I'm going to call this one, I don't know. G something, I don't know. Is that understood with everybody? Your gain is this right here, right? It's a number, right? And then how do you verify this in LTSpice? If you put in 1 volt, 1 volt, V out is going to be multiplied by, actually, what's V out in terms of G and VS? Is that good with everybody? So if you want it, you can simulate this in LTSpice as well. Just put in 1 volt, and if you know your gain, that's pretty much it. Or better yet, let me show you very practical. Here's your output voltage, right? If I do the following, divided by V, Vn, let me color this red. It's the gain of my circuit. Minus 1.25. Does that make sense? What about here? Here's Vn, right? And here's V out, right? I'm going to do V out, color this blue, divided by V of Vn. What's the gain? Minus 10. Does that make sense with everybody? And then why am I typing V out over V in, right? This right here is just V, which is a voltage, and then what's the name of the node, okay? And then you have to name your nodes as well, okay? Does that make sense with everybody? Is there any other questions? I'm going to be giving you guys these files, the practical model and the ideal model. Tell your friends, your classmates, but it's because you guys will be using these op amps a lot. I think for this exam, when you guys are studying for it, especially your homeworks, I think that's due very soon too. And then you will be seeing this next semester too, so don't worry. Some voltage dividers, actually everything you see here is going to be seen next semester. So other than that, any other questions before we head out? So I think we're going to have another lecture next week. Is that what we like? You guys have class next Wednesday? Or are they canceling that for Nevada Day? Okay, so then we'll still have lecture that way. Okay, that's good. So, all right. See you guys next Wednesday, all right? Have a good day.